Hello everyone, welcome to SuMON Student Presentation. Today we have Krishiv Mohan with us, who is going to solve the most difficult problem of the most difficult level. That is problem 8 of level number 4. So in this problem, we are given a sequence of numbers and we take the sequence of numbers through a process and we condense the sequence as we go through the process and we reach a particular final stage and we have to prove certain conditions on that. So now we have to play clever here and get some essential concepts involved in it in order to analyze. Usually the monovariance and the elaboration of the process are the most important factors. Let's get started.
Our problem states that Bob takes 2n numbers from 1 to 2n for some fixed n, and on each move he deletes 3 consecutive numbers in the sequence and replaces them by a plus c minus b if a, b, c are the numbers. And he continues making these moves until only 2 numbers remain, let's say x and y. So we have to prove that y minus x is always a constant and we need to find this constant value. Also later we have to prove that every pair of numbers p and q such that q minus p equals the constant is achievable, where 1 is less than equal to xy, pq is less than equal to 2n. So let us consider an example for n is equal to 5. So we'll have numbers from 1 to 10. So let us select 2, 3, 4 and we will replace it by 4 plus 2 minus 3, which is 3. Now let us select 7, 8, 9, which will give us 8. Then we select 5, 6, 8, which gives us 7. Then we select 1, 3, 7, which gives us 5. So in the end, we have 5, 10 and the difference is 5. And 5 is also the value of n. So n could be the constant or the invariant for this problem. So we will consider 2 invariants. First, the first one is that there are always an even number of terms. So if Bob selects 3 terms, then he replaces it by 1 term. So in each move, he is decreasing the number of terms by 2. So in each move, the parity of the number of terms has to be the same. And since they were an even number of terms in the beginning, there should always be an even number of terms. The second invariance is that if x1, x2 till x2k are the numbers present in the sequence, then Sn equals to x2 minus x1 plus x4 minus x3, so on till x2k minus x2k minus 1 should always be equal to n. So let us check whether this is true. So let us transform xa, xa plus 1, xa plus 2. So when we do that and we get the following equation, and then if we simplify that, then we get that this value is also equal to Sn. So S dash n is equal to Sn, which means Sn is also equal to 2 minus 1 plus 4 minus 3, so on till 2n minus 2n minus 1, which was our original sequence, and this value is n. So if we simplify all the terms in the sequence and we are left with x, y in the end, so y minus x has to be equal to n according to this invariance. So the difference of the final pair is always n, and this is the constant. So this proves the first part of the problem. Now let us look at the second part, which is achieving any pair p, q. And now we have proved that the difference of p, q has to always be n. So we can select a pair k, k plus n, and that would be sufficient to prove the statement. So to achieve k, we must operate on k minus b, k plus b, that are the consecutive terms in the sequence. And after repeating this process a sufficient number of times, we will achieve k. And then we'll be left with some other numbers. And then when we perform the operation on the rest of the numbers, we have to be left with one single number in the other part. So the number has to be k plus n. So we can always achieve k, k plus n, and this proves the second part of the problem. Thank you.
I hope you enjoyed the video. Krishiv Mohan cleverly modeled this process mathematically using the differences of the consecutive numbers, and now this helped us to reach the desired conclusion. Join us to solve more interesting and intriguing non-routine problems like this, and our trial worksheets are for free. You can apply it through the link given in the description. We will meet in the next SuMON Student Presentation. Stay tuned. Thank you everyone. Bye.